Hello friends, welcome to Study Algorithms, and today we would be looking at dynamic programming algorithmic paradigms. Note that this is just the first part of a two-series video. First, I would tell you why you shouldn't be scared of dynamic programming and prove it by giving you a really easy example to simplify the concept in your mind. Then, we would use dynamic programming to generate the Fibonacci series followed by a demo. Check the link in the description below for part 2 of this video, where we discuss the very popular 0-1 knapsack problem and its really simple explanation. Let's get started. Algorithmic paradigms are a way how you can go about solving a problem, and dynamic programming is one of those paradigms. I know for a fact that dynamic programming is a word which even some seasoned programmers fear a lot. But as one of the greatest magicians in the history said, that the fear of a name just increases the fear itself. Yes, I'm talking about Albus Dumbledore. But jokes apart, if you're new here, you should not fear dynamic programming. It is not something that you should try to run away from. I have seen a lot of programmers who would not try to solve the problem with dynamic programming and would try to look up at different methods of solving a problem. That is, in fact, a good approach on how to learn new things and how to find different approaches to solve a problem. But sometimes dynamic programming gives you a very efficient solution in a very fast way. And if you look at it, it seems very intuitive. From this video, I would try to simplify the concepts of dynamic programming for you, and I hope I would be able to relieve some of those fears if you worry a lot about dynamic programming. We would go really slow to understand these examples, and by the end of the video, I hope you would be able to solve them on your own. So, to give you the easiest example of dynamic programming possible, let us go back in time and think about a time when you were just a small kid. Let us say I am your teacher and you are still in kindergarten. Yeah, I'm talking about that kind of a childhood. So, now imagine I show you these sticks and ask you how many sticks are these? What do you do as a child? You would start counting these sticks. One, two, three, four. And you would tell me, hey, there are four sticks. And yes, that is the correct answer. Now, what if I just add one more stick over here? Now I ask you how many sticks are there? As a kid, you would immediately say five. But my question to you is, how were you able to come to this answer so quickly? Don't you need to count these sticks again? What would your answer be? You would simply say that no, why would I count these sticks again? I already know that I have four sticks over here and you are adding just one stick more. So 4 plus 1, 5, and that is the answer. Well, my friends, what did you just do? You applied dynamic programming. And yes, that is as simple as it gets. So you can say that by this paradigm, what you do is you break the problem into smaller parts and you remember the solutions that you have already solved. That means you are not solving the entire problem again and again. In this example, what you did was you already stored in your memory that there are four sticks and hence you do not need to calculate them again. This technique is called memoization, and this is how you solve problems using dynamic programming. So, the next time someone asks you what is dynamic programming, or if you come across a question that this can be solved using dynamic programming, this is the first example that should come to your mind. The basic idea here is break down the problem, solve those individual parts, and store the results somehow so that they can be used further ahead in the problem. I know that this was a very basic example of dynamic programming. So let us look at a real example that you see in day-to-day computer applications. And I hope this concept of dynamic programming will get clearer in your mind. Let us start off things one by one, slowly and steadily. A very good example of dynamic programming is the Fibonacci series. Now, what is a Fibonacci series? A Fibonacci series is a series of integers that is given by this formula. The zeroth term of this series is 0 and the first term of this series is 1. If you need to calculate the second number in the Fibonacci sequence, that would be given by the formula f of 2 equals to f of 1 plus f of 0. Equating this would give me 1 plus 0 equals to 1, and hence f of 2 equals to 1. Going forward, I want to calculate the value f of 3. That would be given by f of 2 plus f of 1. Now f of 2 is 1 and f of 1 is again 1, and hence f of 3 comes out to be 2. Let me just add one more number. F of 4 would be given by f of 3 plus f2, which would be 2 plus 1 equals to 3. So this Fibonacci sequence can be written as 0, 1, 2, 3. Now I would add the previous two numbers, 3 plus 2, 5. Then the other two numbers, 5 plus 3, 8. And then 8 plus 5, 13, and so on. So this is your Fibonacci series. But do you see the problem that we are facing over here? To calculate f of 3, I needed to know f of 2 and f of 1. To calculate f of 4, I needed to know f of 3 and f of 2. What happens when I want to calculate some bigger value? Note that we only know two values of a Fibonacci series in the beginning. So if I want to calculate the value of f6, what do I need to do? If you remember, our formula for calculating the nth number of the Fibonacci sequence was, and hence to calculate f6, I need two values. I need to know f of 5 and f of 4. You can see now that these are problems in themselves. To calculate f5, I need to know f4 and f3. Going ahead, to know f4, I need to know f3 and f2. Going further ahead, I would need f2 and f1. And for f2, I would need f1 and f0. And similarly, on the right side of the tree, I would need f3 and f2. And then again, f2 and then f1. Now we can start to inject these values into the tree. So I know f1 is 1 and f0 is 0. Then I can calculate f2, that would be 1. Now I can calculate f3, that would be 2. Now I can calculate f4, that would be 3, and so on. Similarly, on the right side of the tree, I can start calculating from the bottom. f1 would be 1, f2 would be 1, then f3 would be 2, f2 is 1, then f4 would be again 3, and then I go on to calculate the value of f6. But do you see the problem that we are facing over here? We are calculating these values again and again. f6 needed the value of f5 and f4, and f5 needs the value of f4 and f3. So this entire tree is repeated over here. This means that somewhere something we are doing wrong, and we need to rectify this as programmers. We need to take advantage of the fact that computers can do tasks effectively. So what do you do about it? Why do you need to calculate all these values? Let us have a look at one more approach to solve this problem. Do you remember the small kindergarten child we just talked about a few minutes earlier? That kid had stored some results in his memory. So why not we try to apply a similar kind of concept to this problem in computer science? When you think about memory, you can think arrays, or you can think any data structure you want. But since this problem is relatively simple, I think we can go ahead with using arrays. Consider this array as your brain or as your memory. So you know that f of 0 is 0. So what do? You just put this result in your memory. Now your brain knows that f of 0 is 0. Go ahead. You are given that f of 1 is 1. You put up this result again in your brain. Now your brain knows two values, f0 and f1. Going ahead, f of 2 can be given by the formula f1 plus f0. Now you look up in your brain. You know the value of f1 and you know the value of f0. So you take up these values, add both of them and put them in your brain again. So that would be 1 plus 0 equals to 1. And you put this in your brain over here as 1. Let us take a step further. Now I need to know the value of f3. So f3 would be given as f2 plus f1. In our previous example, we were creating a tree sort of a structure. So f3 needed to be calculated by f2, then f1. Then again you would calculating f2 as f1 and f0. But this time you have these values memorized in your brain. You know the value of f2 is 1 and the value of f1 is 1. And the answer comes out to be 2. So you take up this value and put it again in your brain or your array, and that value goes ahead as 2. Moving forward, let us take up one more example. I want the value of f4. So f4 would turn out to be f3 plus f2. You can again look up these values from your brain. They would be 2 and 1. And hence the answer is 3. You take up this value and again you store it in your brain. Going forward, you can just look back in your brain to know what were the previous results, and you can keep on populating this array. We just applied dynamic programming to find the Fibonacci series. And as some of you may know, this technique is called memoization, which simply means in plain terms as storing the results in some part of your memory. And memory in computer science is a data structure or something like this array. Now, if you are learning dynamic programming for the first time, I would suggest you to take a pause over here and just go through these concepts once again and give it a while so that it settles in your mind. Because the next example that we would be looking at would be a little tricky. If you are a seasoned programmer, then sure, this was just a recap of DP for you. And now we can go ahead to an actual problem where I show you an example of a 0-1 knapsack problem. So, whenever you're ready, check the link in the description below for part 2 of this video. And I promise you that dynamic programming would seem easier.